Hello, hello. I will wait for all of you. I hope somebody will connect today. Today I'm finishing the design with the buck converter LM61440. Last time we worked on the circuit design and schematic design, and today we will start and finish the PCB layout. The converter is not crazy complex, and I believe we will get it done in an hour or so. So I will not waste my time, and let's get started. The first thing is to check the schematic. Previously I make a short review. Basically, there is nothing special on this buck converter. There is a switch node inductor, this inductor plus these 5 capacitors are the output filter of the converter. This is the bootstrap capacitor, resistor as recommended 0 ohm resistor, just a placer for any resistor value. Here is the output of the local of the internal regulator. Here is the switching frequency setting resistor combination, just for the sake of flexibility. Of course, one resistor would be fine, but we have combination of 2, serial combination of 2, so we can set flexibly practically any resistance. Here is the input enable pin. There is an under voltage feature on it, but this time we use only the always on feature. Power good, power good is the signal that the output is in regulation. I guess I have to check it. Let me do it this way. Here is the data sheet. We are talking about power good. Let's check power good. Open drain, power good status. This pin pull up to a suitable voltage through a current limiting resistor. High power, okay, low power, okay. I can see that there is a slight issue in this design, because when the regulator output isn't working, like there is no 3.3 at the output, plus I can see that there is 3.3, but we want 3v3. So I will get it back as it was, like this. If the output isn't working, the power good isn't biased correctly, because there is no 3.3 voltage. So we have to check if it's possible to bias it to 12 volts to the input voltage. If so, I will do it. So high power, okay. So high, it means that there is the input open drain transistor is closed, it's non-conductive. There is no output voltage. There is low voltage, but I don't like it. I don't like this setup, because, for instance, the output is not working. There is 1 volt at the output, and the power good will be biased to 1 volt. What does it mean? Probably it will be 0 volt at the output, but I don't like it. I will check the reference schematic where they biased the power good, and then I will check to the output. Okay, so probably nothing bad, but I don't like it. Absolute maximum limits, absolute rating. This is what I'm looking for. Power good, 20 volts. So this can be tied to input voltage, but the input voltage is allowed to be up to 42. So okay, the datasheet changed my mind. I will keep it biased to 3.3, and we will see. Again, back to the datasheet. We have to check the recommended layout. Here is the section layout with some guidelines, with some general rules, and this is the picture I'm looking for. I'm going to save this picture as a reference screen, even with the legend, like this. Yeah, let me save it to the project folder, like this. Layout, LM44 layout, perfect. Okay, so we are ready to start the PCB layout. Yeah, and when I quickly check the layout, yeah, as we discussed last time, there are two ways how to supply the IC from both sides, from left and to the right, and from right there are two input capacitors. There is the power path, or how they call it. So the inductor is in this way. Two output capacitors, we will have 5 of them, so there will be 3 and 2 probably on each side of the inductor. This is the output. The bootstrap capacitor is probably here. Yes, from the boot pin, yes, to the output. Yeah, this is input voltage. Yeah, connected with the inner layer, they say. Inner ground plane. Okay. So I think the first inner layer will be reference plane. They are blue layer. The second inner layer will be dedicated to power, or maybe the bottom layer, and the inner two will be reference plane as well. This should be better. Okay, so let's finish the quick check. Yeah, there is voltage divider with some feedback compensation. Input capacitors 2+2 on each side of the IC, as we just seen in the reference design. Yes, it looks good. Let's call the ERC. Yeah, there is test point that needs to be annotated, but I think this feature will help us with it. No, where are you? No, I need to annotate it. Okay, the schematic is annotated fully. Now I can run the DRC or ERC. Power flex. Okay. And the ground. Okay, 3 power flex. The usual suspects. We can solve it quickly. So here is the power line, power output. The ground is another power output. The formal power output is the ground as well. Now I have to annotate the power flags, and now the warnings or errors or whatever disappeared. So we are good to go. Second fast check of the footprints. If every footprint is assigned to the symbol, it looks all footprints are targeting into my library, which is what I'm aiming for. And we can go to the PCB layout. I will start with the full screen, and then I will, when I when I will be placing the components, I will use the split screen. So you can see, and as well I could see the schematic for the symbols, because I have to understand the schematic when placing components, because it's very critical to place components correctly. So now I can press the F8, update PCB from schematics. You can see there are a lot of messages about adding symbols, in fact footprints, and no error or warning. This is good, I can update. And here is our bunch of components. First things first, disable the silk screen, disable the values. See, now it's crowded, it's almost scaring, like, yeah, I don't like it. Now when I switch off the silk screen, it's better. When I switch off the values, oh, just a few components, nothing crazy in front of us. You know what we are missing? 4 mounting holes and logo of 𝗏𝗏𝗀𝗃 devices. How could I forget? So mounting hole from my library, there will be 3 or 4 mounting holes with ground connection. So these are mounting holes and 𝗏𝗏𝗀𝗃 devices. Come on, here you are. Great, annotate the mounting holes plus the logo, because the logo is symbol as well. Okay, we are good to go. F8, update PCB from schematics. Perfect, here are our mounting holes, and you are asking where is our logo. Yeah, our logo is invisible because I switched off the first screen. Here is our logo. So let's switch it off again. And now my recommendation is always start with one corner of the future PCB. I like the rounded and nice coordinates, so I started at 1:50. So here is our top left corner. I will start with one mounting hole. Where to place it? Well, here is the position relative to 5.5 is an optimal distance for this size of the mounting hole from this corner. How to mark it? We can choose select point, navigate to the corner, and voila, here is the correct position. Yeah, I think 5.5 will be fine. If not, I will place it 4.4, but I think 5.5 is better, or 4. I don't know. Let's see later. There is no issue with it. So we have our top left corner. I'm talking about the reference layout. Example, here it is. So I can easily import by this function on the menu on the right hand at reference images. There, see, they call it reference images because we use these pictures as reference images. If your picture is too, I don't know, too bright, too visible, you can lower the not visibility, the brightness, the transparency of the picture here in the objects. So I will keep it like this. Now, as I said, I will use the split screen mode with switched off layers because the layer section takes too much space. And now I will make the schematic on the right hand side and the PCB layout here. So what will be in the center or near the center is probably the IC. IC is here. And yeah, I think we can inspire with their topology. of the power path facing upwards. Here is our inductor, pin number 1. As you can see, usually this pin is marked with the circle or a bar, and this pin number 1 of the inductor, it means the beginning of the winding, always should face the switch node of the converter because of some EMI parameters. If you don't believe me, ask ChatGPT, Google it, or don't believe me, I don't care. So here is the IC plus inductor. Let's continue with the input capacitors. We have 4 of them, these 2 and these 2. So let's group them and move it closer to the IC. So here is the input number 1 on pin number 8, and this is second side input 12, pin number 12. So let's say these 2 will be near the pin 8, which is here, and the other ones will be on the other side. So like this, cartridge next to each other, and here is the second pair. Let's start like this. Yes. Okay. What else? Yeah, they use some small package capacitors. We don't need them. We will place the bootstrap and the resistor for bootstrapping circuit, bootstrap capacitor. So these 2 components are to be placed now. Yeah, you can see that I sometimes, yeah, I will do it again. I select the symbols from the schematic, and they are somewhere in the PCB layout. When I press the P key, which means I call the feature pack and move footprints, they are collected in a small group, sticked with the cursor, and I can move them anywhere. So for instance, here, output capacitors, I select all of them. They are like sorted, but yeah, somewhere one should be there, one should be here, the third one should be somewhere in the other part of the universe. So here you can see, when I select all of them in the schematic, they are spread across the PCB. I press the P, and they are nicely packed in a small group, and I can move them near the spot I'm working on. Let's get back to work. Bootstrapping capacitor and the bootstrap resistor near the pin 13 and 14. Yes, it's correct. So here is the capacitor from pin number 14 to the, but I think, oh, it's too big. 14. Yeah, 14 is capacitor. Okay. Okay. So they use like thin track in between these pads. Usually in such with such small packages for the ICs, they almost always not recommend, but in the example layouts there is a via, like via here, and yeah, to avoiding this thin track in between pads of the IC. yeah, the truth is that this IC has quite a big gap in between these pin number 12 and 13. There is exactly 0.73 millimeters. So no, this is fine, but I wouldn't be afraid to use a via. We will see how the layout looks when we start routing. Yeah, I like the symmetry, or at least the minimal aesthetic. So I will move these two capacitors and resistor far from the IC. The reason is that when I manufacture the boards and the IC has after the RFO soldering some small short circuit between these pads that are quite close together. I can measure the gap is, the pitch is 0.5. This is quite small distance, and there is short circuit like thin ball or something, and there the component would be like very close. My soldering iron tip wouldn't fit in this gap, in this space, so this would be quite difficult to repair. So I always keep the distance at least 2 or 3 millimeters between the IC edge and the nearest component. In this case, it's, let's measure it again, is 2.2 millimeters. It's optimal. It can be even more, but 2+ millimeters is fine. Let's get back to work. I'm talking too much today. Here is the capacitor for the local LDO, quite important capacitor component as well. So I will place it, I don't know, vertically or horizontally. They recommend what? Horizontally, I think it's better. Come on, come with me. So the switching frequency setting resistor combination is here, pin number 6. So this should be somewhere here. Pin number 7 is the enable port. This is, let's say, quite unimportant components. These are unimportant components, so we can use it like this. Yeah, quite far from here, probably nothing critical. The feedback is spread across quite a large area. This is good. This is common approach. The impedance is quite low, so the signal is not strong, but not so deep in the noise, so, or sensitive to noise, so it can be far from the IC. Now the components for the enable input leading to pin number 7. So next to the switching frequency resistor combination, and this is the resistor leading to the 0, and this is the input. I will take benefit of these resistors here. Yeah, I'm thinking how to place the probably I will like this. This will be, yeah, it will be better. What else? The power good can be far from anything. Pin number 5. There will be via. Yeah, I think they place it. Power good 5. Yeah, there is via. Yeah, I can't see this resistor somewhere in the another part of the universe. Yeah, can be. even close to the output capacitors. I will keep it here for a while because it's not important component. Bootstrapping. There is a biasing resistor from pin number 1. They place it where? Pin number 1. There isn't such a resistor, but I will try to find a good position. Yeah, there will be a via from the 3.3. Let's keep space for it like this. Yeah, it can work for me. Now let's place the output capacitors. There is asymmetry 2 and 3. I don't like it, but what can I do? So this is the first one, the second one. As you imagine the current going through the inductor back to the capacitors, the ground point is start of the return path. Here is the return path again, and here is the ground connection of the IC. So the reference path will be very short through the inductor capacitors back to the grounding ports of the IC. I will keep some distance, short distance between the capacitors and the inductor. So the other group of 3. As I said, I'm not happy that there is no symmetry in this design, but one can't have everything. So what else is here? Feedback. These feedback divider components and some test points. So let's check the reference. Let's check the reference design. There is the output voltage is here. Here is the VIA to feedback divider, as I probably talking about, but not addressing this particular VIA. So here is the other VIA. Yeah, there is the invisible connection, but these 2 points are connected. So I don't like their topology, but it is a message to us that it doesn't care much about the topology of these components. So we will do our best to make the connection with the center of the divider and the pin number 4. So pin number 4 is somewhere here. So I guess there will be VIA as well. No, there is a connection. So pin number 5 and 4, yes, there will be connection. So yeah, here is the spot for our resistors. So like here will be, I will start here. I will place the bottom side resistor here. Here is the feedback compensation network containing 2 components between 3.3 and yeah, I can see that probably I will change the component placement. Yeah, the fully optimal will be this, but This will work too. There will be via, there will be connection, there will be like this. Okay, this will work. Test point to the output is now feedback. I will be continue with the feedback. So let's grab the feedback test point and place it, for instance, here in the center, like nicely in the center. Here is the output. Where are you? I will use the benefit of, here is missing capacitor, so I will place the test point to the spot where the extra capacitor should be placed, if there is some. Power good near the point, near the pin 5 or somewhere near the resistor R3. I think, yeah. I remember we wanted to place it on a better spot. So I think I will place it here. And the particular test point like here. Here will be nice spot for labels. And I think there is a ground test point. Basically, I wouldn't need the ground point because there are two connectors with double ground connection, but for some measurements I would need the ground connection. I can imagine some noise measurements, or I don't know. So, and enable near the pin 7. Here is the enable resistor R1 and R2. Okay, so in the name of the symmetry, I will place it here. Okay, now input resistor, input header, input connector here, and the output connector will be on the other side. As I said, the symmetry is everything. Not everything, but I like the symmetry, as you probably know. So here is the output resistor. Why I'm saying resistor, this is the header. I am confused. So let's move the components closer to the mounting hole. Let's switch the grid to 0.5 mm and let's place the other. Let's place the other. Mounting hole, here is my reference 0. Can make the PCB layout bigger again. And the distance is something like 34. So I will use the position relative to. The issue with KiCad is that you can grab the footprint anywhere, so you are easily out of the grid. I don't understand how it should work. I thought about that the other day, but I'm still confused. Probably, yeah, I don't know. Yeah, I can grab the footprint like this. This is near the center, it's okay. But when I grab it here, I can move easily out of the grid. This didn't happen now, but I don't know. When I want to display how it works, or how it doesn't work, it works. but when I want it working, it never works. Okay, the other two, I have to count with the space for the logo, the important thing. Yeah, here you can see the mounting hole is placed on some crazy coordinate. So when I use the position relative 2 from this, I'm aligned with the grid and I can use the manual positioning. Here it will be the logo probably, and the other one will be here. So position relative 2, 34 or so, no. Never mind, I am on a grid, so I can easily move it like this. Now, as I said, I can finish the PCB shape. I think like this. Use the shape modification for fillet, 5 mm. Is it okay or not? I think I think 4 is better. No, it's too much, too low. When you measure the distance from the center of the mounting hole, so this is my 0, and here is the distance, 4.5. So to have like harmonically rounded corners, you have to measure something sometimes. Okay, it looks good. Here is our renderer. It will be nice board. So let's route. We have 20 minutes until 1 hour time. I think I will need more time. Let's work on it. Let's start with the switch node. Oh. This was my intention. So I will draw a polygon from U1 switch with some priority, for instance, here, and solid. For now, I will keep the default values, and when I edit the polygon, the KiCad will remember my setup for creating for future, for further work. So it doesn't matter now. Yeah, the snap to graphics work sometimes beautifully, sometimes it's annoyingly snappy. So now when I edit the chamfer fillet, 0.3, let's say, 0.2 is better. Okay, it's nice polygon. It reminds me to edit the port setup. Yeah, 0.5. I think I don't need more. Yeah, it's fine. I think we can work with it like this. The ground will be, how do I use the ground? yeah, this strong ground connection. Okay. The input, yeah, the input will be polygons, definitely. So let's use the polygons from the pads, and I will connect this polygon from the left side to the header, and the right side will be connected with vias. Hi Pawan, how are you? You can see when I started creating a new polygon, the KiCad remembers the lastly entered values. So it's fine if, yeah, this works like this. I think it's a trick. In my opinion, it should work differently, but it works, and this is what interests me much, or most. Okay, here will be our field of vias. Let's create it here. 2 times 5 can be better, can be fine. Yes, but I have to change this setup to source the item, the reference item as the first of all. Should be good. I have to make the horizontal spacing a little bit shorter. This is what I'm looking for. So we said that here is the connection in between these two pads. Why not? Like this. And here is the, yeah, I need to make more space for this track. I think this polygon, yes, this polygon will be affected by this track, and I don't want it. Yeah, one possibility is to use different angle. One possibility is to change the default clearance, because I think it's too low, too high. Not too high, but I will use 0.18, 0.17. Probably it allows me, yes, to rotate like this. Here is the biasing resistor. I think here can be polygon. Yeah, it can. It seems they and where is pin number 3 in the reference design? Here is like area, like island of, or peninsula of ground coming out. Okay, can do that. U1 VCC. Yeah, I'm working on the polygons for the second input side. Like this, here will be not too many, but some vias connected. Yeah, I forget to change the layer count to 4. Layers number 2 and 3 will be on reference plane. Ground with thermal reliefs. Yes. Yes. Okay. Both layers, yes. Yes, both of them. I can hide them. So ground. Here will be the power good. So only yeah, they use it like here. Oh, this looks good. So the 3.3, the big bar, yes. I accidentally deleted the entire polygon, so I have to start over again. Oh, this happens. So again, maybe the shape will be better. It wasn't bad, but probably it should have happened. Should have happened. Yeah, as I get. Yeah, this is the snap to graphics when it's annoyingly snappy. You don't want it. There is no graphics, but it snaps like crazy. Okay, the ground. Ground, 3.3. So probably we don't need via here. We will use it like this. There are some signals. The power good. Here is, I don't know what. Point numbers. Oh, this is the switching frequency setting, resistor combination. Yeah, here's the, okay. Yeah, here will be test point for enable, ground, ground. I will use, okay, I have to move this trace a little bit closer. To have space for via here and here. This is the, what's this? The label. Do we need the critical amount of reference plane 𝗶𝗶𝗺 here? No, we don't. So, and here is 3.3. Yeah, here I will use the via connection. Come with me. No, here, better. Oh, I can see that we can go here. And why to place this resistor vertically, horizontally, when it can be here in the same row as these resistors, nicely routed, nicely placed, like here and here. So let's pour the top and bottom layer with ground, and let's tune the 𝗶𝗶𝗺 on the top side, because we will use this as a heatsink for the IC as well. Yeah, here is the island on under the IC. Let me
head over to brain.fm or follow the link in the description below.
I'm here. I'm back. So I was drawing the polygon for the bottom layer with the 12 volt, because we need to connect the input voltage, capacitors, like this. It doesn't necessarily have to copy the shape of the top layer polygon, but it can. So why not? Okay, so what else needs to be connected? Here is the polygon for, no polygon, test point for the 3.3, and I like the edges to be aligned. It's not possible because the line is too, it's off the grid. But When I draw this polygon, I was on the 5 mil grid. So I think when I set, no, it doesn't work like this. So I wouldn't chase the wind and do it like this. Okay, so let's check the top side copper layer, copper pore. Okay, I think I can make a little bit less clearance, more clearance. Yes, I think that's better. Trying to place the vias, basically anywhere. So horizontal can be 1.6 times 2. How it works? No, too dense. Better, but still not. Can be. Uh, 6 for 2 capacitors, so 9 for 3. Too much. I will move them a little bit far from the connector. This is better. So yeah, and I will add 1 extra row of these and these as well. These will serve as vias for both output and input capacitors. And snapping to the graphics again. It's a nice feature, but sometimes it's too annoying. You know what? This will be better. So where is ground connection? Here. So labels LM 61440. Let's check the size. Can be bigger, so I will make it bigger. No. This way. No, sometimes it doesn't work. No, it will be working. Too much. 3. No. The editing sometimes doesn't work for the 𝗞𝗶𝗖. Yes, this is the correct size. And 9/2025, and I will use exactly the half dimensions. Yeah. So let's Let's remove things we don't need. So sometimes when you grab the reference designators, it grab the KiCad cursor grabs something else. So there is one hint. You can use the dimmed display mode, and here is the maximal priority to the layer you are present in, you are working in. So you can use it sometimes when KiCad plays with you dirty games. So why I'm working on these details like reference designators, the reason is that before I call the design rule check, I have to avoid unnecessary findings, and one of the unnecessary findings and warnings is the select screen overlapping. So this is why I'm working on them, because it avoids the unnecessary findings. Too thick. That's better. Yes, I will use the trick with the array. Okay, slightly far from here. Perfect. Okay, now test points. So I will need these two, 3.3 and the ground. This can be here. This is the feedback. This is power good. Enable. So now we can call the DRC. So how many findings will be there? I think 20. This is like average number, but we will see. 0 and 1. That's better than I expected. Unconnected end. So this is some residuals of the routing. Sometimes there is like short nibble of track without connection. So 0, 0. I think we are good. So I finished the layout in like since the beginning of the stream, 67 minutes, but I talked quite extensively. I think it can be done in half of the time. Now I'm tuning the polygon for the inductor, adding some vias for the ground side here, as well here. I will need to move this slightly higher, like here, and the L1 here. Place the circle inside of the silk screen layer, marking beginning of the winding for the inductor, like here. Here is the pin number 1 of the IC, it's correct. Yes, how it looks. It looks nice. Yeah, the bottom layer. Screen. Let's check the inner layers with the high contrast mode. Yeah, here is the top layer. Quite compact polygons. Copper pore is perfectly surrounding the circuits. Yeah. Here is quite short connection, so I will add 2 wires here and 2 wires here. Okay. Here again as well. So yeah, here is the inner layer. I will use the solid connection. No, I will keep the thermos. I will make the thermos a little bit wider. No gap. The spoke width. Yeah, that's better. The second inner layer, basically it looks identically. And here is the bottom with solid connections. Yeah, the board, the components will be sometimes difficult to connect, but to solder, but we want 4 amps of the output, so I don't want to compromise the connection. These polygons are not crazy extensive. Plus, I will use the reflow heater, so it will be fine. I'm not afraid that there will be issue with manufacturing. Okay, select screen. Okay, again the render. Yeah, I think it looks pretty good. Very good. Okay, we are done. So thank you for watching. See you next week, and I hope these 2 live stream about designing the buck converter would help. So take care, have a nice day, and see you next week. Bye bye.